One ma'am, I'm Nandini from Department of Civil Engineering, second year, studying in MLRITM college. Today I'm going to tell about the minor losses in pipe flow. First of all, what are the minor losses? Minor losses are the energy losses occur due to the disturbances in the pipe flows rather than the friction along the pipe's length. They are caused by the reductions, disturbances to the flow, such as fittings, walls, bends, changes in pipe diameters, etc. The minor losses in pipe flows are also known as component losses. And next I am going to tell about the objective of the minor losses in pipe flow. To determine the loss of head due to sudden expansion and sudden contraction in the pipe flow. Outcome. Evaluating friction and energy losses in pipe flow systems and hydraulic jumps by measuring minor losses. Scope of the minor loss in pipe flow is to know the knowledge in minor loss. The pipe flow is necessary for the design of pipes, calculating velocity and discharge in a pipe flow. First of all, what are the sudden expansion and sudden contraction? Sudden expansion is the loss of energy when the pipe cross section suddenly increases, and sudden contraction is loss of energy when the pipe cross section suddenly decreases. Next, the apparatus used for the minor loss of experiment. Pipe of smaller dia connected to the larger diameter. Pipe of larger diameter connected to the smaller diameter in inlet, outlet valves, collecting tank, stopwatch, etc. Next, the experimental setup to do this experiment is two pipe of cross section area as A1 and A2 ranging together with a constant velocity, the heat flow and from smaller dia pipe. This flow breaks away from edges of narrow edges. Section eddies from and resulting turbulence cause dissipation of energy, the initiations and onset of disturbances and turbulence is due to fluid momentum and its area. And next to this experiment, we need the following procedure. First of all, measure the diameter of the pipes. Next, prime the mercury manometer. Connect the test section pipe to the main water supply. Open flow control valve. Priming test section and pipe work. Open clips on water manometer, allowing water to circulate through the system until all the air is expelled. Close the pipe clips. Read mercury manometers through bleed sewers in conjunction with control valves. Close flow control valve. Observe datum level of manometers. To achieve maximum flow, fully open flow control valve. Note levels in manometer and measure flow rate. Repeat the different control valve position. And the formula we need for sudden expansion is, first of all, calculate P1 minus P2 into A2 equal to Q into A2 into V2 square minus V1 into V2. And solving that, we get HE, head loss. HE equals to V1 minus V2 whole square by 2G. HE is the loss of head due to sudden expansion. And V1 is the velocity of flow smaller section. V2 is the velocity of the largest section. By doing all this, we get the sudden expansion formula, that is Hg equal to 0.5 V2 square by 2g. By doing the experiment, we get this difference in manometer reading, pressure head difference, time for the 10 centimeter rise of water, actual discharge, outlet velocity, plus due to sudden expansion. The first reading we get is difference in manometer reading, that is 25.8. The pressure head difference is 0.98 meters. The time required for this is 15.3. The actual discharge we get by calculating is 5.8 into 10 power 3. The outlet velocity is 47.83. The head loss is 58.3. The next time we get is 25, is the difference in manometer reading. The pressure head difference is 0.85 meters. The time required for 10 centimeter rise is 15.57. The actual discharge is 5.78 into 10 power minus 3. The outlet velocity is 47.03, 09, and the head loss is 58.51. The third reading we get is 24.5, is the difference in manometric reading. The pressure head difference is 8 meters. Time required for this is 16.84. The actual discharge for this is 10.34 into 10 power minus 3. Outlet velocity V2 is 43.51. The loss of head due to sudden expansion is 48.24. And the next one is difference in manometric reading is 24. Pressure head difference is 6.8 meters. The time required for this is 18.72. Actual discharge is 4.807 into 10 power minus 3. The outlet velocity is 39.17. Head loss due to sudden expansion is 39.1 meters. The next one is difference in manometric reading is 23. Pressure head difference is 5 meters. Time required for 10 centimeter rise of water is 21.24. The actual discharge is 4.23 into 10 power minus 3 meter per second. Outlet velocity is 34.46 meter per second. The loss of head due to sudden expansion is 30.26. The last reading we get is 0.34, difference in manometric reading. The difference is 0.131 meters. The time required for 10 centimeter of rise is 20.38. The actual discharge we get is 4.416 into 10 power minus 4 meter per second. The outlet velocity is 3.908 meter per second. The loss of head due to sudden expansion is 59.1 meters. By calculating all these, we get the sudden expansion is the loss of head due to sudden is 46.48. The examples of minor losses are sudden enlargement, sudden contraction, not only the tooth, and the examples for minor losses are pipe entrance, pipe exits, bendings, pipe fittings, valves, etc. The loss of energy caused by changes in flow direction and the presence of fittings comes under the pipe fittings and bends. The loss of energy as the fluid exits the pipe comes under the pipe exit. The loss of energy at the fluid enters the pipe, comes under pipe entrance, and major losses are also known as friction losses caused by friction between fluid and pipe walls. While major losses are typically associated with longer pipes, minor losses are with short length pipes. The importance of these minor losses are accurately calculating and accounting for minor losses is crucial for designing efficient and reliable piping systems. Ignoring minor losses can lead to inaccurate predictions of pressure drop, flow rate, and energy consumption. So, and so this is the about the minor losses in pipe flow. Thank you, ma'am.